Okay, hopefully it goes better than yesterday's regionals. That was bad.
It was bad. Do you guys enjoy the one where it's like mistyping the password question?
Oh yeah, I didn't. Dude, I was about to ask like 10 clarifications about it, but I realized this is virtual. So I was just like guessing. I didn't know if shifts affected special characters or not.
Yeah, we had to assume that as well.
Yeah, so I
Such
just
a bad
guessed.
question.
Alright. Okay, I'll look at B.
Okay, I'll look at A.
Okay, I can code this up real quick if you have a finish reading.
What?
Have you finished reading yours?
No, I'm still reading it.
Okay, I'm gonna code
You
mine
can
up.
code it up. Yeah. Yeah. Okay, A is pretty easy.
Does it not give you an N at the start? Oh wait, no, never mind. It's always two. Wait, I misread the problem. Oh, okay, you can do it.
Okay. A is pretty stupid.
You're done?
I think so. If I didn't misread the question. Alright, we got AC.
Of course, copy examples. ETS. Okay, you're doing C?
Yeah, I'm reading it. All right.
You got it?
I think so. Passes the samples. Are you reading D?
Yeah, I know how to do
Okay, let
D.
me look at it. Let me look at E. Alright, E is just more brute force.
Yo, I might have fake solved this. Yeah, I have no idea if this is right.
C is still running. How many tests do they need for C?
Yeah, they need 100 test cases.
Alright, I can do E real quick. It's just brute force. Okay, C is accepted.
You're doing both easy and hard?
They're actually different. Hard is a counting question.
Oh, counting both. Okay. I'll look at G. Why is it a PDF?
So, are you looking at F or?
F is its hard version. So I'm looking at G.
Okay, I'll look at F then. F is probably just DP. Alright, I'll just do it.
I don't know the math behind G. How do you determine if there are two starting numbers that Fibonacci to like a certain number?
Don't know.
Say I want like X as the kth number of a Fibonacci sequence with like two starting numbers.
1 second. Oh, wait. Hmm. Why is this wrong?
Good question.
Oh, I see. Okay. Well, it should pass samples now. Yeah, it passes samples. I'm just gonna submit this.
Is the Fibonacci sequence binary searchable?
I haven't read the question yet. Let me read it.
No, it's just it just simplifies to like if you have two, determine if there exist two numbers a and b, such that a and b are their starting numbers, such that x is the nth, x is the nth Fibonacci.
X is the nth number. Okay.
Of like two random starting numbers, yeah.
So if you have like A, B, and then you want to make sure that the nth term in this number is x.
Yeah.
So are you trying to verify if that's true, or are you trying to?
Yeah, just see if it exists, if a pair of A and B exists.
Oh, see if it exists. How big is n?
45.
Oh, you can just calculate the coefficients of A and B in the nth term, and then see if you can find numbers that add to the number.
Okay, I can do that. You can look at something else.
Yeah, I'll look at H.
Oh, and A and B has to be co-prime. Does that matter?
Wait, let me think. Well, eventually you're going to get ax plus by is equal to c for some number c, right? So
is it guaranteed that they're if I find a pair, is it guaranteed that it's co-prime? I feel like it's not.
what you can do is, so basically you're gonna get like ax plus by equals c at the end, right? So you can find the solution, and then you can add a and add b to x and subtract a from y. Like, I'm just gonna write at the bottom here. So eventually you're gonna get like ax plus by equals c. So if you found x1, y1, that works, you just do x1 plus b, y1 minus a. And then etc. And then these are all the solutions. So if one of these are co-prime, then it works. Yeah, I think that's how.
Wait, so do I have to verify that A and B are co-prime or find a solution? Like I'm thinking
A
of like
and B are all A and B are always co-prime. You're talking about x and y, right? X and y are the starting numbers.
Yeah. Yeah, the starting numbers.
Wait, how big is the number you want to be?
How big
Like
can it be?
as big?
10 to the 9.
Oh, okay.
Yeah, so I can just move.
Hmm. That's annoying.
Like Diophantine shit. I don't know.
See, why do I feel like it is always possible? Well, like if a solution exists.
Hmm. Okay, this is a guess. Okay, it's not right. Hmm.
Wait, so what is this test case? So you want
So no, so I think you can ignore the 3. It's just 2. So n is the first number. So n is 2, and we want to test 2.
so you want a thing.
Test 2 is possible to
Oh,
be
okay.
like the
So
second Fibonacci number. Well, it
okay.
should always be possible because you can just set it
Yeah.
to anything.
Well, if n is less than or equal to 2, then it's always possible. But
Is that an edge case? I don't.
I don't know what you're doing here. Like GCD of fib n dot first and fib n dot second is always 1.
Really?
Yeah. Because including algorithm things.
Hmm. Getting math diffed. I feel like I've seen it somewhere, like just like some. The other way.
What you could do is solve ax plus by equals 1, and then multiply both of them by c. But that's going to give you something where both of them are divisible by c, so you can just try to make them both positive by adding a to the second one and subtracting b from the first one. But that sounds really annoying to do. Okay, you can figure this out. I'll look at h.
Okay, man. Let's see how it is.
Alright, h is really annoying.
H? What is H?
Basically, you have to use 4 and then the operators plus minus times divides and parentheses to make a number in the least number of 4s possible.
That sounds like an ICPC problem.
Yeah. Well, you can only have 10 4s. You can only use 10 4s in total. Probably just brute force. Like, you generate a list of numbers you can get, and then yeah, it's just brute force. I'll just do it real quick.
Okay. Yo, I feel like this is so standard. How do I not know this? It's actually not.
Wait. Oh god, that's so stupid. Yeah, it's extremely annoying brute force.
Wait, stop for a minute. I just want to try something.
Okay.
Oh, I feel like this should be right though. This is literally like that 1 0.
You know that GCD thing is always 1, right?
But so that means I don't need this condition. It's just.
Do they have to be positive, or can they be negative?
It doesn't say. It just says integers. So I assume they're positive because it doesn't make sense you give someone like negative amount or something. Yo, I have no idea if this is right. Wait, how is it true?
Pretty sure that's wrong. I think.
No, if GCT is always 1, but no, but if they both have to be positive, then they should both be at least 1. Wait, how is this not printing no? Oh, it's less than. Are 1 and 1 positive? I mean co-prime?
Huh?
1 and 1 are co-prime. Right?
Yes. Well, for example, if you want the 5th term to be 6, I don't think that's possible with positive numbers.
Oh wait, this sample fails. Let's draw over. So it says the 5th number can be. The 5th Fibonacci number can be 2. Wait, so they don't have to be positive.
Huh? Then you always print yes. Are you sure you understood the question correctly?
Wait, this is so sus. Yeah, I think I should understand this problem correctly. It just doesn't say. It just says integers A and B. I don't know if it's like only positive or whatever.
Wait, you're given prime factors and exponents? Why would the prime factor
but you only care about the exponents, right? Because you can just add the exponents. And then it becomes like a Fibonacci sequence.
Wait. Hold on. Oh, so their sequence is c sub I is c sub I minus 1 times c sub I minus 2?
Yeah.
Oh, I see what you're doing. So they have to be non-negative integers then.
I guess. Then isn't it just minimum of. They can't just always make one out of 0. So just.
Okay, I agree with you that the primes doesn't matter. So it looks like it has to be Fibonacci with the first integers being like with them being non-negative. Wait, why does it have to be co-prime again?
It says in the statement. It says A and B are co-prime.
What is A and B?
The first two like f of 1 and f of 2. CL1 and CL2.
Wait. Oh, if those are co-prime, then oh, that's easy. So one of them has to be 0. Yeah, okay, so if C sub 1 and C sub 2 are co-prime, that means you can't have a positive exponent in both of them. So you just try the first one is 0, and then try the second one is 0. Because the thing that's co-prime is not the Fibonacci numbers themselves, it's the prime raised to the Fibonacci number. So one of them has to be 0. Like, you get what I mean?
Okay, just passes samples. This thing.
Uh, no. It's really simple because like it says the first two terms must be co-prime. The first two terms are the primes raised to the exponents, and the exponents. So basically, you're saying one of the first two numbers must be 0 in the Fibonacci number. Like if you have ax plus by equals c, then either x is 0 or y is 0. So you just check if c is divisible by a or b.
So C is divisible by fib n of first or fib n of second.
Yeah. No, that's wrong. I think like if they're both not 0, you print no. Otherwise, you print yes. If they're both not 0.
If they're both not 0? Ooh.
Yeah.
Wait, if they're both not 0, then you print no?
Yeah.
Like that?
Yeah, I think so.
Okay. Don't fail past samples, so I'm gonna smack you. Oh no. What, the dividing?
Because fib can be your fib coefficient can be 0.
Let's say
So I think n is less than or equal to 2 is a special case. Just print yes if n is less than or equal to 2.
Yeah. Like that. Yes. No.
I'm a genius.
Yes. No. Okay, so I'm gonna submit this. Imagine passive. I love getting massive. Okay, you can continue with whatever you were doing.
Alright.
Look at I. Okay, it's passing. Okay, you're actually a genius. Okay, after you do this one, I'll need you to confirm my idea for Hey, J is really similar to the series codes probably.
Floating point exception. Okay, I'm sure this is right. Surely. Wait.
Does it work?
Forgot something. That should work now. Uh-oh. Okay, it did not work. Huh. Bro, that's so stupid. Oh my god. I thought like it's never optimal to go to the doubles, but apparently it is.
Okay, J is really easy. I can do it.
I think I'm almost done.
Okay.
Actually, you can do J first. Yeah, I'm gonna fix this later.
Okay. Can you look at I? I can tell you my idea. You see if it's correct. But I'm not sure how to calculate
Okay.
the actual thing.
Let me read it. Okay, so basically you have to go from 1 to A, but you can't go through B, right?
But you can't. No, but you can't like shit around with any path to B. So it's like. So how I understood is basically you go from 1 to A divided by GCT of A and B.
Wait.
It's not like not passing through B. It's like that doesn't share a route with any uh doesn't share with any path from 1 to B. So it's like
Wait, what does it mean by share any path?
So like if you step on like any vertex, it can't be like you can't get to B with it. It can be
Well, can't you always go from 1 to B directly?
I assume it's like path of length at least 2, or else it wouldn't make sense.
Oh, okay, I see. Basically, like you're allowed to be on 1, but you can't go to any factor B, I think. So you're saying it's the number path to A minus the number path.
No, I'm saying it's number of the path to A divided by GCD of A and B. So you first divide A by GCD of A and B.
Oh, okay.
See if that makes sense.
So in the first test case, you will be trying to go from 1 to 3. That doesn't look right.
I guess. Whoa.
Yeah, it's wrong because there's only one path from 1 to 3.
That's broken. Okay. Well,
I wonder if this is just brute forceable with like D squared.
D squared? A and B are up to 10 to the 12. I don't know.
Well, I mean D as a number of factors. Because like if we're using the cube root as an approximation, it should be 10 to the 8. So it should be doable. You know what I mean?
Do you know how to?
So I'm saying like if we're using the square root, the cube root approximation for maximum number of divisors, then we're talking 10 to the 8 if we're doing D squared, which should be okay.
Yo, that's like sus as fuck, dude.
10 to the 8?
I guess you can try, but I just wasn't really sure how to calculate the number of paths. You didn't really get an idea.
Yeah, I mean, like if you brute force, it should be easy, right? I think it's worth a try because 10 to the 12 is not that big.
Wait, are you looking at what else next? K and L are left.
Okay, I can read K. Oh my god, K is an interactive.
Yes, your favorite.
Not exactly. Oh, it doesn't look that hard. Yeah, K is not that hard. I think I have a strategy already.
The answer is not 6. Alright, it's over.
Right, L looks hard.
-1. How do you have a distance of -1? Oh. Okay, you can look at you can do some problem. Whichever you want
Okay.
to do. I mean, assuming this passes. If it doesn't pass, I will murder someone.
Test 5. Oh, wrong answer. Test 27. Let me do I real quick. I think I can do it pretty quickly.
Okay. 27. What? How do you get wrong answer?
Tests are probably. Your tests are probably just bad.
Oh, if P is 0, I'm fucked. I forgot.
Can you fix it?
Yeah.
Okay, just fix it.
Wait, I just want to make sure real quick that I'm fucked if it's P is 0. What is this? Yeah, it's printing impossible. Great. Oh, where is the shit? Okay.
Oh, I see. Is this traveling salesman on a maze?
Well, that's like much easier. You know, I thought about this edge case, but I forgot to handle it. Classic me. Yeah. I'll submit this. Okay, you can continue.
Alright.
Yeah, it passes 27.
Yay.
I just trolled. I just got a right answer for that. Which one are you doing?
I.
Oh, the math one. You're saying K is easy?
It is easy. I mean, like, we just gotta come up with a way of doing the queries. Like, you can read it if you want.
Okay. Wait, you're giving up on H? Or what?
I'm not. I'll do it later. But I seems easier to do. Okay, well, this passes samples. Hopefully it doesn't TLE.
It's 10 to 8. 10 to the 8?
Wait, what do you mean?
Wait, what's the complexity of this then?
Yeah, this should be 10 to the 8.
Oh god.
Plus a log. Surely it's fine. Oh, wrong answer on test 5. Wait, did we misunderstand the question?
Skill shoot.
Oh, I see. Wait. Huh. Why is this wrong though? Okay,
Yeah,
screw I.
That's interesting.
Wait, can you reread I and tell me why the code I just submitted is wrong?
Lil bro, I don't know what you're doing.
It literally just brute force. Like,
It is.
I think our claim is wrong. Like,
Wait, what's your claim? What was your
well,
claim?
basically, it can't pass through any factors of B, right?
It doesn't have to be any factors. It just a route isn't just one factor. You can go up one factor and go up another, and you can still reach B.
Wait, can you come up with a counterexample?
I don't feel like it, but it's obvious, right? It's like if you go like if you take like the I think like 1 to 6, and then so if A is 6, and then you might go to like I don't know, 111. Wait, you can only go to a multiple, so it's not hard to construct.
I think you just can't go to any factors of B, and that's it, right? Well, clearly that's wrong because I just got wrong answer. But why would that be wrong? Anyway, so I'll just keep working on H while I think about this.
I know why it's wrong. I just don't know how to construct it. I just don't know how to calculate that. Wait, so you're saying you can't go to any factor that is also a factor of B? That's what you're saying?
Yeah. How am I doing this?
Are you sure it's not GCD BNX?
Which question? Oh,
Your I.
1 second. Let me do H.
Because if you, it doesn't have to be a factor. Just. Oh no, maybe that's not true.
Alright, do we trust that this is correct?
I feel like L is small or large.
Oh, it passed test 1. Alright, nice. I got H.
I'm just thinking about L right now. As for I don't know. I don't think my counter case works. It's a weird problem.
Oh wait, I think I see what's wrong with the I. Because I use int instead of blown long.
Where?
I had for int I equals 1, I times I less than equal to A.
This guy.
I could try to resubmit this.
Are you gonna resubmit?
Let me just run to make sure this. Alright, so this is wrong.
Oh, A can be bigger than B.
Of course, but
what happens then?
Oh, it overflowed. But they said it's guaranteed it's not gonna overflow. Should be fine. This should be fine. Let me just submit this. Wrong is on test 5. Yes. Fuck. Alright, okay, do you want to solve K? Because like I have an idea on how to do K, but I just trying to figure out the queries. Like I'm sure it's possible somehow, but
I'm thinking about L. K? Oh, not really. I'm thinking about L. L is interesting.
Pretty sure L is the hardest question, so.
L feel like some weird smile large. I have L reduced to basically the minimum label on the path, maximum label on the path minus minimum number of labels on the path is number of vertices minus 1. Okay, I'll read K if you want.
Yeah, I should probably read K.
I feel like L is like I would be good at it, but I'm not sure right now. Oh, so you just make them fight 1v1s, and then you want to rank their strength.
Yeah, but basically, like if you can ask your queries in a way that reveals like pretty much just like how every person fights against everyone else, then you just get the answer immediately.
Well, you can make up to n queries?
Yeah.
Is that like a lot?
It is a lot because
well, you could like construct a graph or something.
Yeah, that's what I'm saying. But the thing is, you have to do a permutation every time.
Permutation? What do you mean?
I mean, like, okay, so you have 4 queries, right? So, I mean, you have like n queries or whatever. You basically need to do the queries in a way that it reviews, like, it basically reveals how strong everyone is against each other. Like, I'm sure that's possible, right? Construct like n of them so that every single person's performance against every other person is revealed.
I don't know, I'm like stuck on my graph idea. I mean, n is a lot, so you could like make everyone fight each other once.
Yeah, that's what I'm saying.
Wait, if you make everyone fight each other once, then isn't it easy to get the answer?
Yeah, but how do you construct the permutations?
So that everyone fights each other once?
Yeah.
Is that hard?
I thought it would be easy, but apparently it isn't for anything bigger than 4. Like what you could do is for every single person, keep a list of people that they haven't fought yet.
Okay.
And then just do it greedily. But does that guarantee that you'll get all of them?
That sounds kind of sus.
Yeah, it does, but it should work. I'm willing to give it a try.
I'm down for it, and to just like print out the first few and see if just observe if it works. Let's just try it. Wait, smart or large is just you swap the largest children up, and that guarantees a lot of complexity.
Yeah, I think so.
Not sure how to solve it out.
Does this look right for length 8?
1, 2.
I'm sure it's right.
You're only playing 7 rounds. It's
Yeah.
I guess that's right.
It looks like it works. Okay, I'm just gonna do this then.
Okay. Then you construct the graph.
Yeah. Well, we don't need to. Just how many wins each person has.
Not true.
And then a line of n over 2. Okay, cool.
You're the tournament tester. Wait, you go from strongest to weakest.
Oh, bruh. Problem solved. Well, you can't really test it locally.
You can test it like it.
I can test it on custom invocation. Oh, you can't.
Yeah, you can't. You just have to like.
I'm just gonna submit this.
That's crazy.
Why is it just stuck on test 1?
That doesn't sound great.
Oh, it's at test 3. Okay, I'm sure it's right then.
What? No. Bro, celebrating too early. No, test
This
19.
should be... Oh,
Okay.
19. We're good, we're good. Okay.
Oh, we just guessed this.
Yeah, no idea why this works, but by symmetry, surely. Accepted. Let me just try to understand what I is again.
Yeah, I'll probably help you because L is.
Wait, do you want to
hard.
do you want to do I? Do you want to do I and I'll look at L?
No, I don't know how to do high. I'm like having the
I
same
just need
questions
to
as you. I'm not sure
Yes, you also-
why like division's not great as you. I haven't found a counter case yet. I thought I did, but I didn't.
Well, I don't think there's a counter case because you just can't move to any factors of b. Because if you move to a factor of b,
Yeah, you can just go straight to b. Yeah.
Yeah.
What if you don't go straight to b? Then it should still be a factor of b, shouldn't it? Because you can only move to like a factor, a number that is a factor, and it's like a number
yeah,
that
you
is
can
a
only
factor
get to
of
a
factor.
factor. Yeah, because a factor of a factor is a factor. So any of the paths from 1 to A that share a route with any path from 1 to B is now
Does
not
it have
safe.
to do with like you're not handling A is greater than B, right? Because I haven't really thought about that.
What do you mean?
Does that matter if A is greater than B?
It shouldn't.
Sus. I mean, L seems like some like data structure. I just don't know what it is. It's also pretty annoying. You have to like rename the vertices.
Let me read it. Yeah, 4 seconds, probably some kind of square roots, honestly.
Yeah, everything above 3 seconds is square root.
Or like 2 logs.
It's more likely 2 logs.
So the answer could be O of n squared, right? Because
You're
yeah, if
talking
you
about
just have a
L?
linked list, yeah. If it's a linked list, it's just O of n squared.
Well, yeah.
That's the answer.
I mean, you can think about it. I'm gonna tell you my idea, but I don't know how to implement my idea.
What's your idea?
So you can arbitrarily root the tree, right? And
Sure.
so it's basically.
Wait,
So I think it's just basically just saying it has to be like a connected path, right?
Yeah.
And so if we rename the vertices to like, so you don't care about the vertex numbers, you only care about like the edge numbers. So if you rename the vertices to like as like the number of the edge that connects it to its parent, then it's basically just the minimum like vertice label, like the maximum vertice label minus the minimum vertice label is the length of the path.
Interesting.
Like, +1 -1 something. But I'm not sure how to like count that. Like if you're at a, so you can iterate over like the least common ancestor of the path, right? And so well, wait, does it even have to be a path? It doesn't have to be a path.
It doesn't have to be a path. It just has to be a connection component, I think.
Yeah, it's like a connected component. It doesn't have to be a path. A path is not necessarily a connected component. You can have like a triangle, whatever. In that case, I don't know what to do. Cause it's not like even like binary searchable.
I think like what I'm thinking is for every single path, you find the first one, such that, like let's say you're on the ith what do you call these edges? Yeah, let's say you're on the ith edge. You find the first edge such that I from J is a connected component, and then you do something with like. And then you do some counting with like what you got from J to count the ones that start with I.
Wait, I don't get what you mean. It's always a connected component.
Well, yeah, but like, let's say for like the graph that in the picture, right? So
Yeah.
the first one is 4 because you need 1, 2, 3, 4 is a connected component, but 1, 2, 3 is not. So you find this,
Okay.
and then like you do something with the result from 4 or something like that. Actually, is that even true? That might not even be true.
Oh, this is annoying because a tree doesn't have to be a path. I thought it has to be a path. So let's.
Yeah, it doesn't. I think we should do I first. Like, try just figure out what I is, and then just
Alright.
deal with this.
People at UC Davis is too smart.
Oh yeah, it's California.
Okay. So, what the heck is wrong with I? We've established that there's no way you're overcounting. Is there a way that you're undercounting?
I don't think so, because like if you're going to a factor of b, that means you're going from a factor of b to a factor of b, and then there's definitely a path from 1 to b that uses that one, right? You know what we can do? We can just spam submit and try to find what the test case is.
Wait, can you try using in 128? Because what if, wait, you know how answer A is like guaranteed to be long, right? What if like,
no. It says it's a guarantee that the answer fits in the 40,
I know, but if
bit.
answer of A is 64-bit, is there a possibility the answer of X is not? Because you set it to 0 right after.
I don't think so, because wait, what do you mean? You're saying that is there a possibility that one of its factors have an answer greater than 64-bit?
Yeah.
That's not possible because if
Maybe
it's 0, it gets set to 0
because
anyway.
you get set
but
to
if it's
0,
not
yeah.
0, but if it's not 0, then it's at least that. Then the answer for A is at least that.
So it's kind of doomed.
We could like try to reverse engineer the inputs.
What, you wanna like binary search asserts?
It's one thing we can do. It's like
In the ICP2 contest, would you do it? Just binary search assert and get a year of penalty.
I mean, I don't know, unless you can figure out.
It's 2 numbers too, so it's like, I don't know. So you have to like binary search one, and then you have to binary search the other.
Basically, yeah. or we can try to figure out why this could be wrong. I mean, their samples are kind of just trash. That's the thing.
If A is greater than B, then if
No,
X is a factor of X, it's a factor of B, then it has to be. And if it can get you A, it has to be a factor of A too.
Again, so like any of the possible paths from 1 to A that share a route. So routes are just a linked to path, right?
Length
so
2 or more,
I to J.
I guess. It's length 2 or more. Yeah.
No, a route is just from I to J. Okay, so any path from 1 to A that shares a route with anything from 1 to B is not safe.
Okay.
Okay, screw this. I'm gonna write a brute force.
Why'd you delete the O thing?
I cut
this
it.
This is stress test.
Oh, wait.
It's annoying to write brute force.
Of course. So we have to generate all the paths from 1 to B. And then set those edges as bad. And then... Yeah. Okay.
That's not too bad.
Okay, sure.
Mask?
Because all possible ones, right?
Oh, I thought you were just going through its factors.
Well, we could, but also clearly something's wrong here.
Well, this is like you can't do any numbers above like 18.
I mean, solve is already a brute force, basically.
Yeah.
Why would this be wrong? Do you know the fragment that kills it if it overflows? You want to use that?
I don't know what that is.
Apparently the fragment that kills the program if it overflows.
It's not necessarily that a vertex is bad. Then you can it's like an edge is bad. So you can still go to like a vertex that connects to a bad edge.
No, you can't though.
Why not?
Well, the only way you can go to is 1, because if there's a vertex with a bad path that goes to B, that means this vertex is a factor of B. Which means it would have been, the path that the last vertex you were at would have also been bad.
Makes sense.
Yeah, I'm just gonna keep writing brute force.
Wait, so 1 is never a bad vertex. But what if you go to like say you go from okay, I'll try to construct the counter case. You keep writing.
Alright, yeah. Okay. This is so annoying. I don't even want to write the brute force.
It's not even guaranteed it works because you only use it for numbers so small.
Alright, this question is cringe.
If only I knew how to solve L.
I'll take a look at L again.
Wait, so if it's a tree, then surely it's not like those generic path algorithm things. But what else could it be?
I'm sure it's casework on like the last edge that you use. Or something like that for L.
Casework? Wait, well, I don't know what you mean by last section use.
Like for the first one, you start with the last edge being 2, 1. I mean the first edge being. Okay, if you're doing casework on the last edge, like you can do casework on like if the last edge is 5, 6, in which case it's only 1, and then you can do last edge is 3, 1, and then it's also 1.
Okay.
Yeah, like I'm sure it's something to do with that.
Casework. Is it really casework? I don't see the cases.
But the cases are which edge you use last, right?
Wait, in that statement it says, note that the TLR form may not be a tree, but it must be a forest. So if you
yeah.
if it's like multiple trees, is that still good?
No.
Wait, no.
Because no matter what you do, it's always multiple trees.
Wait, I'm like tweaking right now.
Oh, what if What if you do complementary counting?
So
Casework on the number of
find
connected components.
find all the ones that are in the tree.
Yeah, like casework on the number of connected components.
Casework?
Yeah, casework on the number of connected components. I mean, I don't know. That sounds hard.
On the number of connected components. Wait, okay, let's try this off. What if it's not a tree? Is there an easy way to
Then
do
it's
that?
yeah, this question a bit hard. You know what? Screw this. I'm gonna spam asserts on I. Codeforce is not loading for you.
Is it?
Yeah, the pages aren't loading now.
Yes. Codeforces, my favorite website. Still
It's
ran.
like it knows I'm about to spam submissions, so it's like
Like nope.
so just block me.
Wait, actually the complementary counting is a good idea.
It looks like just the problems are not loading.
So if it has more than one connected components, then it's automatically bad. So you just want
Yeah.
to count the number of ones I give.
Oh, okay, loaded.
You just want to count the number of stuff. Well, you actually need a binary search.
I don't think so. I don't think it's binary search. All right, so A is less than 10 to the 6
Okay.
for test case 5.
Try 10 to the 3.
Sure, I'm gonna try 10 to the 3. It's less than 10 to the 3. Interesting.
So A and B can't be that big.
Yeah. I'm gonna try less than 50. And now it's not loading again.
So if you delete consecutive edges, then what happens? If you delete consecutive edges, then
Wait. I just got an idea. So let's think about it this way, right? Like, let's say you have, for each consecutive edge, you calculate the minimum and the maximum of everything between it. So if you want these two to be together, it needs to be at least as big as that and at least as small as that. You know what I mean?
No. Wait, are you talking about the labels?
Well, yeah, the labels of the edges, right?
Okay. Like consecutive labels? It just was consecutive labels?
Yes, yeah. So like for example in
CSF
in figure 1, edge 1 and edge 2, the largest one between them is 4. So if you want 1 and 2 to be together, it needs to be at least 4. And then and after that you can just do a 2 and 3 and a 3 and 4 to find the new smallest and largest if you want to use 1 and 2. Like, you know what I mean?
Wait, so you're saying if you want 1 and 2 to be together, you need 3 and 4? Or
yeah,
you just care about the maximum one? Actually, that makes sense.
Yeah.
Maximum
it needs to be at
minimum
least 3 and 4.
Yeah.
It needs to be at least 4. And yeah.
You care about the
maximum of this.
Care about the minimum too.
Yeah.
So if you have that information.
If you have that information, and then I think it's like some type of DSU, right? Because like you have it's either DSU or like small to large merging, because
no, small to large doesn't work because it's not necessarily a path, so it doesn't make sense to small to large.
No, like small to large in a different way. Like if you want 1 and 2 to be together, you need 3 and 4, right?
What? A is less than 50. That's interesting.
Wait, that's crazy.
You're filling out some small ass numbers, bro.
What would a brute force be like? What would a brute force look like? Like a really stupid brute force.
You see, just try to go from like 80 to 1, like go backwards, and count.
Isn't that the exact same as what we're doing?
Well, no. You figure out the B first. Okay,
let's assert B is less than 50.
Wait, so you are cooking on L, so
yeah, so 1 and 2 you need 3 and 4. Okay, and then runtime error on test 5. Okay, so B is bigger than 50.
Try 100.
This is so funny.
It's so dumb.
So like, what if you create this new tree? Like you have 1. Oh, so B is less than 100.
Here, let me see the complexity of people who solve this. Oh, it doesn't show, so 0 ms. Okay.
Did anyone solve I? Oh, they did solve
Yeah,
I.
just like people who didn't solve H but solved I.
The actual hell?
The team didn't solve F but solved I. I think we're trolling.
The question is just unclear.
Wait, so for each consecutive edge, you know the minimum label and the maximum label that has to be in it. So what if what if you fix that minimum? Then
No, because if you want to use, wait. No, because just because you're using everything from the minimum to the maximum doesn't mean that's valid. Because something else in there could need some other things to work. Like, for example, if the path from 1 to 2 goes through 5, but just because you use 1, 2, 3, 4, 5 doesn't mean it could work, because maybe 4 and 5 actually require 7 or something like that. So I think like this is why I'm thinking like you build some other tree from this information.
okay, is consecutive even, right? Why don't you want to consider edge 1 to edge 3? You still want to like get all well, edge 1 to edge like some other like.
Well, of course, consecutive matters because
well, consecutive,
I guess
but non-consecutive also matters, doesn't it? I think the sample is just like.
Well, no. Look, if you want to use 1, 2, and 3, the necessary and sufficient condition for that is 1 to 2 has a minimum of 1 and maximum of 3, and 2 to 3 has a minimum of 2 and a maximum of 3, or something like that. Like if you want to use from L to R, the necessary and sufficient condition is that every pair of consecutive ones in that range lies in the range.
Okay. I thought it wasn't true for a second.
Alright, I'm gonna keep binary searching for I. I mean, I honestly don't even know what I'm gonna do once I find the actual test case. Like,
you're just finding it for
we don't know
nothing.
what it's even asking. We don't even know what it's asking. And it's not loading again. Great. Like once you calculate the smallest and largest in the path between them, then
I think you're overthinking of like constructing some other tree. I think there's some easier way. Like if basically if we do this, we can model like the problem on like an array, right?
what do you mean?
Basically, you can model the problem like if we get the max and the min, we can model it on an array. Right?
I mean, sure, yeah, that's true. And they're just looking for how many good ranges there are where the minimum and the maximum actually matches. I mean, yeah, okay. So, well, we first of all
so
need to...
let's think about how to solve this on an array once we have that information.
Okay. I think you can just casework on what the smallest edge that you use is.
Yeah, so I'm thinking too. What if you fix the smallest edge that you could use?
Then that means the min of your range should be equal to the smallest edge. But also the max should be equal to the max.
Yep.
I think you just keep a prefix. You could just use. I think you just solve that with a segment tree, right? Is it? Because you need the min of this range to be because you need the min to be equal to I, and the max of I plus 1 to j equals to j. Oh no, okay, so we've
Could it
solved the
just binary
so
search? Well, say
it's not binary search.
you fix the min, right?
Uh-huh.
You have you find the smallest one to the left, such that like it's a number smaller than a min. So obviously you can't include that.
Yeah, but not
you
everything
also
between the words.
you also wanna make sure it's like everything in between is not greater than a max.
Yeah, that's the hard part because not everything between this range works. I'm sure this is the right idea though.
So can I just like binary search for like the greatest left?
No, because it's not. Basically, not everything in this range works. Like you can find the upper bound of what could possibly work. Not everything in this range will work. Uh, Is there even a way to figure out the minimum and maximum in this for every single path?
Yeah, that's easy. You can use like some like binary lifting.
True.
Or even easier, HLD. No, the problem is that it's just solving a problem on an array, assuming your idea is correct.
I mean, of course, this should be correct, but yeah, I guess solving an array is non-trivial.
I'm still thinking, what if you fix the smallest edge?
Oh, wait. I think I know how to solve on an array.
Yeah, I think I do too. You gotta fix the left and binary search for like the max, the binary search until like the least, such that the max is greater than whatever.
Yes, but not everything between them works, but I know how to solve that. Basically, you have these ranges, right? So for each I plus 1, you have L to R, right?
Yeah.
So if you fix I to I plus 1 as the smallest edge that you use, then you can binary search for largest possible one. Basically, find the J such that L of J is less than I. So upper bound is J minus 1. So after that, you realize that like
Wait, so
The
so
one
you're
from
saying the edge from whatever this label is I from L I one is equal to L. Is that what you're saying?
I'm saying that this is the smallest edge that we use.
Well, then it has to be L, right?
Yeah, so L, that means L of I should be equal to I.
Yes, yes. Okay.
And then we basically need to find the ones where the R of the range is also R. But basically, like if you have like max of R from I plus one until K, if this is equal to K and the min L is equal to I, then this works.
Yes. So the second's obviously monotonic, right?
Yeah, the second one is obviously monotonic, but the first one
First one,
is not.
I feel like it's standard though.
Well, I mean, it is monotonic, but
well, you want to count how many satisfies.
yeah.
Phew, I feel like it's standard. It's annoying.
It does look standard. Maybe this is the part that you square root decomp or something.
Nah. You're high. Definitely can be solved with symmetry. I'm just thinking about how.
Well, okay. First of all, we know that the max of R is at least K. And that's because the max from K minus 1 to K is at least K, so
Yes.
that makes it simpler, I guess.
Can you do like stacks? Like
I think you
can't have like something to the left that's greater than K. Like the closest one that's well
no, you need to find the number of them in like log time. Because we're looping through this. We're looping through I. Of course, finding the answer for whether a single range works is easy. I think it's something like.
Do you want me to start implementing like the first part and you can think about the second part?
Sure. Go ahead.
We have what, how many minutes?
26.
Is that enough?
I don't even know. I don't think it might not be enough. Well, you can try implementing it.
Oh fuck.
I think I have an idea. Yeah, I'm gonna wait for you to do your thing first.
That's good. Okay. It's annoying that the vertices doesn't matter. It's the edges. It's a bit.
Yeah.
Do you have to do casework on them? Well, no, it doesn't matter. 1 and 2 can be exclusive. It doesn't matter. So it's just like to one of the vertices it connects. You do a vertex query.
Yeah. I think like which one you actually query doesn't matter. Yeah, which one you actually query doesn't actually matter.
But let me think about this. But it's essentially, so say you want a path from 3 to 4, but you don't want to like get 2 in there. That's really annoying. I'm like high right now. So is
Oh
it?
wait, what if? Yeah, you go ahead.
No, wait. Are you talking about like my implementation or your idea?
My idea.
Okay, go ahead.
I think after you get the min and max, you can do complementary counting because if you have I plus 1 is the range L to R, this means that because of this edge, everything left of R that contains this doesn't work. And everything right of L that contains this doesn't work. But the problem is overcounting. I think you could just do some type of monotonic stack. Let me think about this some more.
Wait, what if I just represent the edges as vertices? Is that smarter?
Honestly, might
I
be.
construct a new graph basically, such that the edges are vertices.
And the ones, yeah, I think that's smart.
Okay, let me cook. Man, I wish we had more time. This sucks.
Yeah, we spent too much time on I, and I is just stupid.
Oh my god, I haven't used this template in so long. I don't even remember how to use this template. Oh shoot. Okay, I remember. Wait, do you have an idea?
I have an idea, but I don't know. I don't know if it works.
I thought you cooked up like some complementary chemistry.
It doesn't exactly work. I'm thinking like casework on the smallest element and complementary count.
Bro.
Wait, that actually should work, actually. Ah, okay. It's a bit annoying, but it should work. Wait, is the first part already done?
Almost. I haven't used this template in so long. I don't even know if this is correct.
You can like just print out the things.
AI equals. Is it inclusive? Yeah. Okay. Let's see if this works. Oh, we have 13 minutes.
Might not work.
C++ 4 bits me. Oh. Oh no. That's not right. Sus. What? Wait, it's all 0. Hello? Is there nothing in this? New graph? Oh wait, this is not getting done in 10 minutes.
Yeah, unfortunately, I think I have something. Like you can look at what I wrote in the
we can still
comments.
keep trying to solve. Just try not to overcomplicate. Yo, why is there nothing in my graph? Hello? I'm clearly putting shit in the graph. What? Yo, my DFS not DFSing. Fuck. What's happening? What's my... Did I forget how to implement DFS? Zero, one.
Yeah, I think I know how to solve the second part of the problem. I'm convinced my thing works.
Okay, you can start coding it. Well, once I figure out why I can't DFS right now. I'm so confused.
It's a bit annoying to code.
Oh, why is my DFS not DFSing? 0, 1. What?
I also need you to sanity check me and make sure my logic is
I
correct.
forgot. I'm so dumb, bro.
Oh, here we go. Is that right?
Oh no, check.
Let me see here.
It's the last triplet thing.
Yeah.
Okay, you have 7 minutes.
I don't think it's getting done in 7 minutes because it's a bit annoying.
My guy.
Wait, is that just a sample graph? Is this just a sample graph?
Yeah, it's a sample graph, yeah.
Oh, okay. 1, 8? That doesn't look right.
From 1 to 2?
There's...
Oh, it's not 1, 8. What the sigma? Why did I get 1, 8? Oh. Wait, it's 0 indexed, so
But 1A still doesn't look right. It should be 0-3 or 1-4 or something like that.
Yeah. It's not even a 9th edge. How do you make it a 9th edge? Okay, it's Drover. Yo, so many teams solve I, but no one solved H, J, or K. Are we like trolling or what?
Apparently.
Or that looks right. There shouldn't even be a 9th edge. How do you even have a 9th edge?
Wait, how are you constructing the new tree?
Isn't it easy? Just DFS down the edge. So I treat edges as vertices. Why doesn't this work?
I don't think it works, because like, what are you doing with like the node 4 in the picture? So are you adding 4 and 7 to the adjacency list of 3?
No, what?
Wait, how are you constructing the new tree? Tell me.
Yeah, 4 and 7 are to the adjacency list of 3.
So wait, but is 4? So hold on. So you have 3 and 4 as an edge, and 3 and 7 as an edge.
Yes, I think so.
But is 4 and 7 also an edge?
No, why would it be an edge? They're children's.
But how does your program know that?
I'm DFACing.
Wait, so you...
Wait. You can take a look for yourself. It's really short.
Okay, sure. So edges now push back UV.
Wait, this the DFS thing. That's like just the normal.
Okay. So where are you constructing the new tree?
Here, 170.
Oh, you're constructing it there. Are you sure that that's correct? I mean, okay, yeah, the print stuff out in the DFS and make sure it's right, I guess.
Okay, 3, 1, 2, 3. One index this.
So these are your 6 edges?
Yeah.
Shouldn't there be 7 edges?
I don't know that, bro.
I don't think your new construction thing is correct.
Wait, look at the edges first. 1, 3 is an edge. 3, 4 is an edge. 3, 7. Where's
Hold on.
Where's 3,
So
7?
1, 3 is an edge. 2, 4 is an edge.
Wait, where's 3, 7?
Yeah, your thing is wrong. Your thing is wrong.
4, 7. Oh, it's saying 4, 7 an edge.
Oh, it says 3, 4, and 4, 7.
What?
Wait, so which one is missing? 2, 8 is missing, by the way. 2, 8 is missing.
Interesting. Interesting. How's 2, 8 missing? Yo, I actually don't see what's wrong with this. Okay, I'm gonna try this. Should we?
Are you ever
so I'm
visiting?
starting the DFS from 0.